Now we're going to look at systems that have three planes in them. Now the difference between three planes and two planes is when we have two planes and three variables, you're missing an equation for the algebra to actually figure out the entire solution for you. So that's when you have to inspect normals to figure out what's going on and do they intersect at all or do they intersect in a line, because you have to introduce a parameter, because when you're short an equation, three variables, two equations, it's not possible to get a unique solution. Hopefully you looked at the content though and realized that there are all sorts of options for how three planes can intersect or miss each other when they're in a three-dimensional Cartesian plane. So because we have three variables but three equations, we can jump right into solving. You could pair them up in sets of two, eliminate one of them, solve, and then work it back. But this is where we're going to use an augmented matrix. A matrix is just an organization tool. It's a way to write the information in a way that's easier to handle. So I'm going to take these three equations and then write them in an augmented matrix. It just means that our first column represents our coefficients of x. Our second column will represent the coefficients of the y's. The third column will be the coefficients of the z's. Then we put a line to represent that's where the equals would be. And our fourth column represents the answers or the constants once they've been moved over to the other side. Now, in Gauss-Jordan elimination, we want to turn these three corner values here into zeros, because then we can start reading off z equals this, move it up, y equals this, move them both up, and x equals this. So the first two things I'm going to do is I'm going to get a 0 in those two positions. So my first row is not going to change. But for my new second row, I'm going to take row 2, that's this one up here, and subtract 2 row 1s, because that way these numbers will match when I multiply this by 2, and they will subtract to 0. Some people can do it in their head. Some people prefer to actually multiply this row by 2 off to the side, because now instead of going 2 subtract 2 times 1, negative 5 subtract 2 times negative 3, they can work over here. 2 subtract 2 is 0. Negative 5 subtract negative 6 is positive 1. 1 subtract negative 4 is positive 5. And 3 subtract negative 18 is positive 21. Now the second 0 I want to get is right here. So I'm going to take row 3, but in this case I'm going to add 3 row 1s because they're already opposite signs, so I don't need to subtract to get them to go away. So again, you can just do it in your head, or if you want to, you can multiply 3 of these right now. So I just tripled all of these, and now I'm going to add these together. Row 3 plus 3 row 1s. So negative 3 plus 3 is 0. 6 plus negative 9 is negative 3. 2 plus negative 6 is negative 4. And 8 plus negative 27 is negative 19. Now the last 0 I want to get is right here. I have to work with these two rows though, so these zeros maintain each other. If I go back and work up with row 1, the value in this first spot will undo or get rid of those zeros. So in this case, my first row is going to stay the same. My second row is going to stay the same. And to get this, I'm going to take row 3, which is this one, and I'm going to add 3 row 2s, meaning this row 2 up here. That way, those zeros will guaranteed maintain themselves, because no matter what I multiply by, those will be there. Again, you can do it in your head. This one I think I will. So negative 3 plus 3 times 1 is 0. Negative 4 plus 3 times 5 is going to be 11. Negative 19 plus 3 times 21 is going to be 44. So I've created my zeros. That's always what you're looking for. And now I'm going to pull information out and work up from this. So from here, this is the z part. That means 11z equals 44, or z equals 4. Then I'm going to go up to the next row, which says 1y plus 5z equals 21. So y plus 5 times 4 equals 21. That will give me y equal to 1. I'm going to move up to the top row. 1x minus 3y plus 2z equals negative 9. So x minus 3 plus 8 equals negative 9. I just used 1 and 4 for y and z and multiplied. And that's going to give me x equal to, let's make sure I wrote these down right. So negative 9, subtract 8 is negative 17, plus 3 is negative 14. So therefore, these planes intersect at a point because I was able to get a unique solution, and the point is x, y, z. So let's look at another system. I still want this underneath. So because I have 3 variables or 3 equations, I'm going to go to a matrix so I can solve. 1, 1, 2, negative 2. Now the important thing here is in this third equation, there are 0 z, so I have to represent that in my matrix as the coefficient of z is 0. I'm going to work to get my zeros there and there. So row 1 will stay the same. I'm going to do row 2, subtract 3 row 1s. Feel free to multiply row 1 by 3 off to the side. I'm going to do it in my head. 3 subtract 3 times 1 is 0. Negative 1 subtract 3 times 1 is negative 4. 14 subtract 3 times 2 is 8. And 6 subtract 3 times negative 2 is going to give me 12. Here I'm just going to do row 3 subtract row 1 because they match already. So 1 subtract 1 is 0. 2 subtract 1 is 1. 0 subtract 2 is negative 2. Negative 5 subtract negative 2 is negative 3. So now I'm going to work here. You can work with how they are, but you can also reduce this into lowest terms because each of these terms are divisible by 4. So I'm going to do 0, negative 1, 2, and 3. And now I'm going to have 0. Now I'm going to do row 3 plus row 2, but I'm actually going to use the reduced row 2. So I'm doing 1 plus negative 1, which is 0. Negative 2 plus 8 is 6. Negative 3 plus 12 is 9. And I've done something here. So divided by negative 4. This one's supposed to end up being no solution, and I'm getting a solution. Oh, because I jumped back up. That's what I did. Okay, I reduced this to that. Now to get this row, I'm going to add these two here together. 1 plus negative 1 is 0. Negative 2 plus 2 is 0. Negative 3 plus 3 is 0. Okay, so I just was getting confused with working up there, and you could work up there. But when I put them together, this is what I end up with. Now I'm going to pull this out and think of what it means. 0z equals 0. So that means z can be anything because it doesn't matter what number I put in for z. 0z is always going to equal 0. If I had 0z equal to 3, that would be no solution. But I get z equal to t. And so now these are going to intersect and align. I need to figure out the rest of my parametric parts for my line by, again, working up. This is going to be similar to what we did with the 2 planes. So then I get negative y plus 2z equals 3, which is negative y plus 2t's equals 3. I'm actually going to bring the y over here. So y is 2t minus 3. Now I need the x. X plus y plus 2z equals negative 2. So x plus 2t minus 3 plus 2t equals negative 2. So x is going to equal 1 minus 4t. So therefore, these intersect and align. And the solution is x equals 1 minus 4t, y equals 2t minus 3, and z equals t. But here's where we have to be careful, because if they ask for a geometric interpretation, they want to know what it looks like. For 3 planes intersecting a line, you can either kind of get that pinwheel effect, where all 3 planes are non-parallel, or you can have 2 planes that are the same, and then one that cuts through them. So if they ask for a geometric interpretation, we have to go back and figure out, is it all 3 are not parallel? So, and I'm not good at drawing these, but they all intersect in a line. Or is it 2 coplanar planes and one that cuts through them? We look at that by looking at the normals. This normal is 1, 1, 2. This normal is 3, negative 1, 14. And this normal is 1, 2, 0. So I can see that none of the normals are parallel. So therefore, we have 3 non-parallel planes. So the geometric interpretation would look like this. This is the algebraic interpretation, but we have to be careful with 3 planes because there's more than one option for some of the different types of solutions. If 2 of these normals were multiples of each other, then I would know, okay, they would have to be the same, because if they're not the same plane and 2 are parallel, there's no solution because the 2 planes are separate. You only have to go back and do this if they ask for a geometric interpretation of what's happening. So number 3, I'm going to go right to my matrix. So I'm going to do row 2, subtract row 1. 1 subtract 1 is 0. 1 subtract negative 2 is 3. Negative 1 subtract 3 is negative 4. And 4 subtract 9 is negative 5. I'm going to do row 3, subtract 2 row 1s. 2 subtract 2 is 0. Negative 4 subtract negative 4 is 0. 6 subtract 6 is 0. I'm doubling all these numbers because of that 2. And 5 subtract 18 is negative 13. So in this case, I ended up getting my zeros right away. So I'm going to read this off, and I get 0, z equals negative 13. So this is no solution, because negative 13 divided by 0 doesn't exist, or there's no number that you can multiply multiply 0 by to get negative 13. So this would be no solution. Again, you're done unless they ask for a geometric interpretation of what the system looks like, because no solution is 3 options. Either the planes kind of make a triangle and they never all touch at once, or we have 2 parallel planes that are separate from each other and the third one that comes through, because the solution is where they all meet at once. If it just asks for the solution, you're done, no solution. If it asks for a geometric interpretation, that's where we have to do the extra step of looking. And these caught my eye right there, because normal 1 is parallel to normal 3, therefore plane 1 is parallel to plane 3, so therefore I have 2 parallel planes and a third non-parallel. And the important thing is that the parallel planes are distinct. I know that because there's no solution. If these were actually the same plane, then I would have a solution. That's the line. So my geometric interpretation looks like that. And one more. So to get my first 0, I'm going to do row 2, subtract 3 row 1s. So 3 minus 3 is 0. 1 minus negative 3 is 4. 1 minus 12 is negative 11. Negative 2 minus 15 is negative 17. Again, I was multiplying all of these by 3. And now I'm going to do row 3, subtract 5 row 1s. So 5 subtract 5 is 0. Negative 1 subtract negative 5 is 4. 9 subtract 20 is negative 11, and 1 subtract 25 is negative 24. Hoping I did all the numbers right. Again, feel free to write them out on the side. So now my last zero is going to be easy to get because row 2 and row 3 line up very nicely now. Okay, I'm going to redo that matrix. It got a little bit sloppy. I just didn't have my rows lined up. 1, negative 1, 4, 5, 0, 4, negative 11, and negative 17. And I'm going to do row 3, subtract row 2, meaning these ones up here. So that will maintain that 0. That will be 0. That will be 0. And that will be negative 7. So I get 0z is equal to negative 7. Which again indicates no solution because you can never multiply 0 by anything to make it a number. They just ask for the solution, I'm done. If they ask for a geometric interpretation, then I have to go back and take a look at my normals. And none of these normals are parallel, so I have 3 non-parallel planes. So the geometric interpretation is going to be the ones that create a triangular prism in the middle. And if I could draw, this would be better. But if you look in the content where I actually copied pictures, you'll be able to see it. But the 3 planes never ever touch at all. They create this triangle space in the middle.